What if I told you that slashing your framing costs by an unbelievable 40% might only actually move your total bottom line by about 6%?
Yeah, that math sounds completely backwards, I know.
Right. But usually when we talk about innovation in construction, there's this profound disconnect between like the shiny marketing and the actual mud on the job site.
Oh, absolutely.
You know the feeling. You're scrolling through your feed late at night and you see this slick time-lapse YouTube video. It's a robotic arm just effortlessly squeezing out these perfect layers of concrete.
No weather delays.
Exactly. No missing materials, no guys calling in sick, just pure futuristic magic.
Right. I mean, it looks like a sci-fi movie. It is totally mesmerizing. But as a contractor, your brain immediately goes to the brutal logistics of it all.
Oh, 100%.
You're watching it thinking, okay, sure, but how do I actually pull permits for that?
Yeah.
Who's running the machine? And what happens when a hose clogs or the whole system just breaks down in the middle of a pour?
And that is the core tension right there. It looks perfectly clean on a screen, but then you step onto a real job site, and suddenly that futuristic vision just crashes into reality.
Yeah, it gets messy.
It does. We're looking at a technological leap that is, honestly, wrapped in a lot of hype right now. So, welcome to this special Scaling Legends deep dive.
Glad to be here.
If you're a construction business owner tuning in, you already know the industry is shifting beneath our feet. Today, our mission is to cut straight through that flashy YouTube hype.
We have to.
We're breaking down the hard numbers behind the commercial launch of Icon's Titan 3D printer. We want to know, what does this technology actually mean for your bottom line, your crews, and your competitive edge?
Because frankly, we have to separate the actual industry disruption from just, digital distraction.
Precisely. And to do that, we are dealing strictly in facts. Everything we're covering today, the metrics, the timelines, the cost analyses, is drawn directly from Smart Business Automator's Market Intelligence Report.
Right.
We're getting into the actual ground-level economics of this shift.
And we really need to talk about this right now, because this isn't just some conceptual prototype sitting in an R&D warehouse anymore.
No, not at all.
We are talking about actual purchase deposits being placed by real builders today. We're talking about true multi-story building capabilities that completely redefine project scopes.
Which is huge.
It's massive.
Yeah.
And perhaps most importantly, we are talking about monumental institutional grade validation from the military. This tech has officially crossed the threshold from an interesting experiment to a tangible commercial reality.
Okay, let's unpack this, because to understand if the Titan is a threat to your current business model or, a tremendous opportunity, we first have to separate what this machine actually builds from what the mainstream headlines claim it builds.
Yeah, the headlines can be pretty misleading.
Very. So let's look at the commercial launch details. Right now, Icon is taking $5,000 refundable deposits. Customer training kicks off in Q3 of 2026, and the first deliveries are slated for early 2027. Now, here are the core specs that jump out. The Titan has a 27-foot print height.
Which is a total game changer.
Exactly, because it completely unlocks multi-story builds. It is not just a little robotic arm anymore. It's a full gantry crane system that surrounds the entire footprint.
Right.
And the cost. They are printing wall systems at roughly $20 per square foot.
Wow.
Yeah. When you compare that to conventional wall systems, which, depending on your region, run anywhere from $33 to $45 a square foot, you are looking at roughly a 40% cost reduction on the walls alone.
And that 40% number is the one making all the headlines, obviously. It is a staggering reduction for a single scoop of work.
Mm-hmm.
But we really have to look at the underlying mechanics of how it actually achieves that.
Yeah.
Because the material they're using isn't just standard concrete you order from a ready-mix plant.
No, it's totally different.
Right. It's a proprietary Portland cement-based mixture called lavacrete.
Which brings up a huge operational question for me. If you are pumping concrete up 27 feet in the air, how does it not just slump into a giant puddle the second it leaves the nozzle?
Yeah, that is the secret sauce of the entire system. It's honestly a masterclass in rheology, which is the science of how materials slow.
Okay.
Think of the printing process less like a traditional concrete pour and much more like a high-stakes, industrial-scale hot glue gun.
Ah, glue gun. I like that.
Yeah, the lavacrete has to be fluid enough to pump continuously through hundreds of feet of pressurized hose.
Yeah.
But the absolute millisecond It leaves the nozzle, it undergoes this chemical and physical transition.
Just instantly.
Instantly. It has to immediately hold its shape and begin curing so that by the time the printer completes the circuit and comes back around, which is often just a few minutes later, that bottom layer is structurally sound.
Wow.
It has to support the weight of the next layer without sagging a single millimeter. And once it's fully cured, we're talking about roughly 6,000 psi.
That's incredibly strong.
It is. It's totally comparable to heavy-duty commercial concrete masonry.
Well, I love the hot glue gun analogy, but I do want to clarify the limitations here because, the machine doesn't just drop a finished turnkey house onto a lot.
Definitely not.
The best way I can think to describe the output is like buying a highly advanced, fully automated car chassis.
Right.
It is an incredible structural foundation.
Yeah.
But you still absolutely need a mechanic to drop in the engine, wire the electronics, and stitch together the interior.
Exactly.
The Titan prints these incredibly strong lavacrete walls, but it does not pour your foundations. It does not frame your roofing systems.
No.
It doesn't do your mechanical, electrical, or plumbing. And it certainly doesn't hang drywall, paint, or install cabinetry.
That analogy hits the nail on the head. And this is where we have to synthesize those numbers to find the true economic impact for a general contractor.
Right.
Because wall systems generally represent about, 15 to 25% of the total cost of a residential or light commercial project?
Yeah, usually.
So yes, you are saving 40% on the walls. But when you zoom out to the entire project budget, your total overarching cost savings is really only about 6 to 10%.
Okay, so a solid margin boost, but not the 50% total project discount the headlines imply.
Exactly. However, the true revolution isn't just in the material cost. It is in the labor efficiency and the speed of execution.
Let's talk about that speed, because the labor metrics are where the math really shifts.
Right. So imagine a standard 2,000 square foot home. To frame those exterior and interior walls conventionally, you need a crew of 4 to 6 highly skilled tradesmen.
And they're working for roughly 2 weeks.
Exactly. With the Titan system, a 3-person crew can print that entire wall system in 24 hours of actual print time.
That's insane.
It is. And it's a completely different type of labor, too. You have one operator monitoring the digital toolpath on a tablet, one technician managing the dry mix silo and the water ratios at the pump station, and then one person walking the print line just to ensure the nozzle remains clear and the bead is laying down perfectly.
So 2 weeks of back-breaking framing gets knocked down to 24 hours of machine operation.
Yep.
That completely changes the velocity of your capital. I mean, in a market where you literally cannot find enough skilled framers to keep projects on schedule.
Oh, it's impossible right now.
It really is. So replacing a 2-week, 6-person bottleneck with a 24-hour, 3-person operation, that is a substantial lever for scale.
It absolutely is.
Here's where it gets really interesting, though, because if the labor math changes that drastically, the natural next step for you as a business owner is identifying exactly which trades in your network need to pivot immediately,
Right.
and which ones are about to get a tremendous workflow boost. Let's contrast the winners and losers here.
Okay.
If you're a CMU, a concrete masonry unit contractor, you are facing a direct, almost existential threat in certain markets.
For sure.
Because the 3D printing systems compete for the exact same institutional, commercial, and retaining wall applications that block layers have dominated for decades.
Yeah, they're in direct competition.
But wood framers have a bit more nuance. If you are framing single-lot, custom infill homes, you're pretty safe for now.
Yeah, the logistics don't make sense for that yet.
Exactly. The cost of transporting, assembling, and calibrating a large-scale gantry printer for a single site simply does not pencil out.
Yeah.
But if you are framing 50-plus unit production developments, you are absolutely threatened.
100%.
We are already seeing this with Icon's 60-home development in Austin, the one designed by the Big Jark Ingalls Group.
Yeah.
That is the exact use case where repetitive wood framing gets priced out.
Because the material efficiency and the speed at that scale simply crush traditional stick framing models.
But let me push back on this for a second.
Sure.
I see the efficiency on paper, but I'm highly skeptical about the margin for error on the job site. If I'm an MEP contractor like a plumber or an electrician, I'm looking at this and sweating. Well, on a traditional build, if the BIM model is off by 2 inches, a plumber just grabs a drill and cuts a new hole through a wooden stud. It takes 5 seconds.
Right.
But if a 6,000 psi solid concrete wall is printed and the conduit chase is in the wrong spot, isn't that a catastrophic jackhammer level mistake? Do I actually want this massive robot on my site?
What's fascinating here is that the reality on the ground is actually the exact opposite of that fear.
Really?
Yeah. Roofers, finished trades, and especially MEPs are monumental beneficiaries of this system. You have to remember, the Titan isn't just blindly pouring concrete into a dumb form.
Right. It's a digital file.
Exactly.
Yeah.
It's executing a highly precise digital toolpath. The machine can be programmed to simply stop extruding material for a few inches as it moves along, creating these perfect hollow vertical chases and horizontal voids.
Oh, wow. Okay.
The walls are printed with perfectly placed integrated plumbing channels already built into the structure. MEP contractors are actually reporting that this makes rough-in work significantly faster.
Because they aren't fighting the framing.
Exactly. There is no measuring and drilling through dozens of studs, no routing around unexpected framing obstacles or weird HVC ducts. Your paths are perfectly clear, perfectly plumb, and exactly where the digital model dictated.
That makes a lot of sense.
It compresses the overall project schedule, meaning your trade partners get in, finish their rough-ins, and get paid much faster.
And because those profit margins and schedule compressions are so obvious, there is blood in the water. That's why we're seeing a global race to capture this market.
Oh yeah, the competition is fierce.
Icon isn't the only player on the board. You have European companies like Cobud partnering with GE to build their own systems.
Right.
You have Apis Core making moves, Mighty Buildings pushing prefabricated composite panels, and SQ4D out in New York. There is serious capital flowing into competitors right now.
There is, but we need to look at why Icon is currently leading the pack and really building a significant structural moat around their business.
Okay, let's hear it.
It comes down to three specific advantages. First, the 27-foot vertical reach we mentioned earlier. Most early printers were restricted to single-story structures.
Right.
Unlocking multifamily and light commercial drastically expands their addressable market. Second is their proprietary lavacrete material science, which we discussed. But the biggest, most impenetrable moat is the institutional validation.
The military contract.
Yes. They secured a $62.8 million contract with the U.S. Army to build multi-story barracks at Fort Bliss.
And that is the ultimate trump card.
It really is. I mean, when the Department of Defense trusts your structural integrity, your ballistic resistance, and your longevity for troop housing, it completely changes the conversation you have with local municipal building departments and private developers.
Oh, absolutely.
It proves durability at scale.
Which is the biggest hurdle when you are bringing something this radical to market.
Yeah.
You need an entity with incredibly deep pockets to prove it works in the real world. And with that military validation securing its foothold, we need to map out a realistic timeline for our listeners. When does this technology actually hit your local market? And what strategic moves should you be making today?
That's the million-dollar question.
Because beyond just time savings, there is another monumental efficiency driver here that we haven't touched on yet, and that's waste. Think about the last framing job you walked.
It's a mess.
Right. Think about the overflowing roll-off dumpsters filled with warped 2x4 cutoffs, cracked drywall, and plywood scraps that you literally paid for twice.
Yeah.
You paid once to purchase the material, and a second time to haul it away to a landfill.
It is one of the most painful, hidden margin killers in the industry. And
according to Smart Business Automator's Market Intelligence Report, waste reduction is a huge factor driving adoption. Conventional framing generates about 8 to 12% material waste on a site.
That's a lot of wasted cash.
Even traditional concrete masonry creates 5 to 8% waste through broken blocks and mortar drop. But because 3D printing is purely additive-like, the machine only extrudes the exact mathematically calculated volume of material needed. The waste is under 2%.
Wow.
That is a staggering amount of money that isn't ending up in a dumpster.
It is a profound reduction in variance and financial risk. And tracking the timeline for when this level of efficiency becomes the norm is crucial for contractors listening right now.
Mm-hmm.
Let's map out the next 5 years.
Let's do it.
From 2026 to 2027, we are purely in the early adopter and military build phase. We will likely see fewer than 500 of these 3D printed buildings completed in the U.S. total.
Pretty small sample size.
Very small. The systems will be going to developers who reserve their spots early from master plan communities. Then, from 2027 to 2028, we hit the true scaling phase. If those early deployments perform well, expect the major publicly traded production builders, the Lenners, the D.R. Hortons, to start heavily piloting this tech. But the main bottleneck during this phase won't actually be the technology itself.
Let me guess.
It'll be the red tape of permitting.
The dreaded building codes.
Precisely. Right now, if you build a house with wood studs, the code is prescriptive. The city inspector brings a standardized checklist, verifies your stud spacing, and you're approved.
Thanks and easy.
Right. But because 3D printed concrete is considered an alternative material under the code, almost every single build requires expensive, project-specific engineering stamps and exhaustive reviews.
That sounds like a nightmare.
It is. That administrative friction is your actual bottleneck, not the robot's print speed. Finally, looking at 2028 to 2030, that is when we expect the 2024 International Building Code updates to be fully adopted locally, which will smooth out the permitting process.
Okay, so that's the turning point.
Exactly. During that window, expect 2 to 5% market penetration, specifically in labor-strapped Sunbelt states where the weather allows for year-round printing and the building departments tend to be a bit more progressive.
So what does this all mean? If you are a mid-market general contractor doing, say, $10 to $50 million a year in revenue, should you be writing $1 million check right now to reserve a printer, train a crew, and just try to get ahead of the curve?
If we connect this to the bigger picture, my advice is strongly no.
Okay.
Do not buy a Titan right now unless you are a massive production home builder with a guaranteed permitted pipeline of 50 or more identical units per year.
It's just too much overhead.
Way too much. The capital investment, the maintenance, and the mobilization costs simply do not pencil out for one-off custom projects or sporadic infill builds. Instead, your blueprint for action today is all about strategic positioning. You need to explore print-as-a-service partnerships.
How does that actually work in practice?
Well, instead of owning the machine, you contract with a specialized operator. They handle the logistics of bringing the printer and the specialized crew out to your site.
Okay.
They print the structural walls over the course of a few days, they pack up their equipment, and they leave. You, as the general contractor, handle the site prep, the foundation, the roof framing, the MEPs, and the interior finishes, just like you always have.
So it's basically just a new subcontractor trade.
Exactly.
Yeah.
You also need to get your hands dirty, though. Go visit the demonstration sites in Austin or wherever they pop up next. Walk the structures, feel the walls, see it in person.
Yeah, you have to wrap your head around it.
And strategically, you need to closely track your local municipality's adoption of those alternative materials building codes. The absolute biggest mistake you can make is dismissing this as a fleeting gimmick.
Oh, for sure.
Treat this technological shift exactly like the early days of building information modeling or laser scanning. The guys who crossed their arms and said, "We don't need lasers, we have tape measures," are largely no longer in business.
Navigating sweeping technological shifts, whether it's figuring out how to successfully partner with a 3D printing operator or just scaling up your day-to-day operations to handle more volume, requires a dialed-in, highly efficient business model.
Absolutely.
You simply cannot adapt to the cutting edge of construction if your team is currently getting bogged down in administrative chaos, hunting through email threads for lost RFIs or spending hours every evening manually typing up daily field logs.
It is the ultimate irony of the construction industry, isn't it? We build these incredibly complex, highly engineered physical structures that will stand for a century, but the internal operational processes holding the business together are often just built on fragile, disorganized spreadsheets.
Which is a perfect pivot to talk about Smart Business Automator. They are the sponsor bringing you this deep dive, and they are the AI platform built specifically for construction companies that want to scale aggressively without drowning their project managers in paperwork.
It's such a necessary tool.
It really is. Imagine taking the brutal administrative burden completely off your team's plates. Smart Business Automator provides automated daily logs and meeting summaries. It literally turns long, rambling field reports into clear, assignable action items instantly.
That alone saves hours a week.
Oh, easily. And the RFI assistance is incredible. It generates draft responses using your specific project's historical context, so you aren't starting from scratch every time an architect asks a question.
And because it integrates seamlessly via API with your existing accounting and ERP software, those daily logs and RFIs aren't just sitting in an isolated silo.
Exactly.
The data flows directly into your financial reporting.
Spot on. It even features predictive schedule risk detection, automatically reviewing project activity to identify potential bottlenecks before they snowball and derail your timeline.
Proactive instead of reactive.
Exactly. Add in the automated compliance checking against your specific project specs, and it is the ultimate tool to give your team the power to handle significantly more project volume. Your PMs finally get their time back to actually manage the build, and your leadership team gets crystal clear, real-time visibility into budget variance and overall project health.
When your project data is organized, actionable, and accessible through natural language search, you stop reacting to daily fires and start proactively managing your margins.
So if you want to give your team the world-class tools to manage more projects without the inevitable admin burnout, you need to check them out. Visit smartbusinessautomator.com to learn more about how they can custom tailor their AI workflows specifically to how you run your construction business.
Highly recommend it.
And for everyone listening, if you gained some actionable insight from this deep dive today, take a second to subscribe to Scaling Legends on your preferred platform. Leave us a rating and a review. It genuinely helps other ambitious contractors find the show. And most importantly, share this with your colleagues, your project managers, or your trade partners who need to understand exactly where the industry is heading.
This raises an important question, something for you to chew on as you head out to your job sites today.
Let's hear it.
We spent this entire time talking about the speed, the labor efficiency, and the cost of 3D printing. But there is a profound design element we barely touched, because this is an additive, digitally controlled process. Printing a sweeping curved wall, an organic shape, or a wildly complex geometry costs exactly the same as printing a boring, flat, straight wall.
Wow, I didn't even think about that.
Right. For the entire history of human construction, complex architecture meant exponential labor costs. If the financial penalty for creative architecture completely disappears overnight, how will that fundamentally change the literal shape and feel of the neighborhoods we build tomorrow?
That is a wild thought to leave on. You go back to that slick YouTube video we mentioned at the start, and you realize it isn't just a digital fantasy anymore.
It's here.
The robotic arm isn't just squeezing out wet concrete, it is laying down the foundation for an entirely new way of thinking about what is structurally and financially possible on a job site. The mud, the sweat, and the grit of construction aren't going anywhere anytime soon, but the tools we use to build the future, they are already here.